Hello, my name is Elizabeth, and this is,
Margate.
Ryan.
Christian.
Kevin?
Brighton.
and we are Current Solutions, providing current solutions to your current problem.
This semester, our team has been working for a solution for our sponsor, Toshiba, concerning uninterruptible power supplies, or UPS for short. Currently, they have a customer demand for parallel control scalable systems. What they currently have is a single-phase UPS system with modules that can be paralleled with other modules of the same type.
The motivation for this parallel configuration is so that a greater power rating can be supplied to your load. This will allow loads to be able to be driven that couldn't be driven with one module by putting multiple modules in parallel. However, a downside of this configuration is that you will see circulating current if the modules are not outputting the exact same current.
Our mission is to reduce this circulating current by supplying a control system to support each module. This will allow each module to communicate with each other and maintain similar current outputs.
Toshiba's current setup involves 5 modules, 1 master and 4 slaves. This hardware must remain the same as we work towards our solution. On the software side, they have already implemented phase measurement as well as communication between the master and the slaves.
One of our improvements is through virtual impedance. Every component has a certain variance. Due to this variance, each of the modules will have different output impedances, which will cause each of the outputs to have different currents. Using virtual impedance, we plan to control the output to vary the impedance, so that way each of them has the same impedance output, so that way they can output the same current.
Now, before we can actually deal with the control scheme, there's another pressing issue that relates to the communication between modules. Currently, the data being shared between modules has to do with the voltage averages over a set course of time. This voltage average is calculated over a half cycle, which means that it takes an entire 8.3 milliseconds to calculate. However, the goal of the system is to be able to communicate between modules every 4 milliseconds. This results in an excessive set of redundant information being shared between the modules. Us at Current Solutions, our goal is to be able to reduce that redundant information sharing so that it's only dependent on either the set of sampling rate or the delay of simple communication. To do this, we are implementing a circular buffer, which should ensure that new data is being sent at every opportunity.
A UPS system ensures that power is supplied to a load even when a power line is cut. Now, due to over-designing a system is not fiscally ideal, so we can assume that this UPS system is very important to protecting the load and the circuit as a whole. Therefore, we are using the utmost concern in making sure that our circuit is not only effective, but safe and well done. Thank you. We'll now open it up to questions.
What is just briefly, your plan for design stage 2 or design 2?
We are looking into implementing virtual impedance, which we are using the current feedback loop to change the variable using an FPGA, and we'll be using that with to use the pulse width modulator to change the impedance output.
You'll have that hardware, you build that test set?
They've already got the hardware in place.
Okay.
We're going to go down to Houston in January and take a look at Toshiba's hardware. They don't want us to change anything with the hardware.
If I understood what you're saying, you're trying to use multiple sources and to produce more current, but the problem is current sharing is always a problem.
Yes, sir.
And so you're trying to, yeah, that's a tough problem.
Yes, sir.
Have you considered constant current circuitry? I don't see it on there.
They don't want us to change anything with the hardware is the issue with that. So we're kind of limited to what we can do with the software, like in PSIM, and kind of what we can do with code to try and. That's why we've got the virtual impedance, so we can kind of trick the system into producing the same current, or within close to the same current anyway.
And can you say a few words about, quote, virtual impedance?
Virtual impedance uses the feedback current loop to change the amount of current that's going to the reference. So in implementing that, it'll change the pulse width that is going to each IGBT on the output of the inverter.
So you're trying to measure the impedance?
We're trying to change the impedance.
It'll add an impedance between the inverter and the load so that it takes the impedance you have and adds a certain impedance that will determine via control loop.
It's impedance control.
Yeah, it uses, yeah. it
So you're
tricks it
taking the
to-
low impedance route and adding impedance to balance it all out?
Exactly.
Yes.
Yes, sir. Yes, sir.
How much variation improvement does that represent? You said it was plus or minus 10%.
That is our goal for the
Right,
next
what does that
semester.
represent as an improvement compared to the current technique?
Right now, they're at what, like 21?
From, I believe it was 21% was
What the current
currently.
Toshiba
Yes, sir,
power
I
spec
think
is?
it's about 21.
We just sent them the code for the circular buffer, and they said they're going to do testing over the holiday period. So then when we come back in January, they'll have better representation.
What about smoothing circuitry? Again, I don't see any on there.
That circuit is basically just our base representation while we were still waiting for NDAs to get through. They have different filters and whatnot in place already.
Do you have any goals for achieving certain efficiency as you start to change the impedance of the different UPSs?
Not currently, that's something that we will look into though, going forward, for sure.
All right.
Thank you.